Welcome, everybody. I'm going to give a global presentation about the living lab Hedwige-Prosperpolder. I do this also in name of my Flemish colleague Patrick Peters from the Flanders Hydraulics. And my name is Ludolph Wentholt for the STOWA, Foundation of Applied Water Research, kind of research organization for the water boards in the Netherlands. When you look at this, you see the polder as it was, before it was depoldered. You also see that you see the harbor of the city of Antwerp on the opposite side of the River Schelde, and on the right-hand corner you see the center of the city of Antwerp itself. So you see it's and on the bottom you see the drowned land of Schaftingen. So you see it's a quite interesting area where you have a lot of different functions combined. And the levee you see in the front, that's a levee what will be depoldered. And that's the levee where we did all the experiments. Now I'll show you a small movie, an animation on what the purpose of our Interreg Polder2C project was. So I'll start in the animation now.
Polder2C's, a unique opportunity. Climate change is affecting the countries in the 2C's region faster and to a greater extent than was previously expected. Rising sea level is a serious threat. We can improve our knowledge of how strong our flood defences are. We can improve how we organise our emergency response in practice. We have a shortage of trained water managers. Knowledge is not being transferred from one generation to the next. And we need to increase public flood awareness. The Hedwige-Prosperpolder is being transformed into new tidal nature. This offers a unique opportunity of a 6 square kilometers living lab environment where Polder2C's can conduct all kinds of experiments. Failure tests are being carried out and emergency response is being practiced under controlled but very realistic conditions. Polder2C's is part of the Interreg2C's Emergeny program. We are focusing on 4 activities: testing flood defences, practicing emergency response, improving our knowledge infrastructure, and building a field station. We are researching the strength of flood defences. We are doing this by conducting destructive field tests and a survey. The Polder2C's project will develop an action plan for international collaboration and innovative tools to improve flood defence. We will design new and better emergency response plans by doing levee inspection exercises, testing emergency measures, initiating controlled breaches and closing them afterwards, and preparing for European crisis exercises. We will formalise knowledge transfer and educate the next generation of water managers. We want existing and new knowledge to be easily available and accessible. That's why we are organising winter schools. Besides this, we are organising levee challenges, and we are developing educational videos, toolboxes, and many more practical educational solutions. We are building a field station at the project site. It will be used during and after the project for educational purposes, research, and as a special meeting place for exclusive occasions. 13 partners from the 2C's region have joined forces to deliver the Polder2C's project, supported by 34 observer partners. Together, we aim to prepare the 2C's region for the climate change challenges that lie ahead. Our partners are the real stars of this project. They make adaptation to climate change happen. To see how you can contribute, find out more on www.polder2cs.eu.
Now you have seen the animation of Polder2C, and you see that the main 3 topics of the Polder2C were flood defences, emergency response, knowledge transfer, and building of the field station. Now I show you a picture of the area, how it is after the depoldering. In fact, how it's looking now. You see they've made 3 big creeks from the River Schelde. And the nice thing about the creek system is that the whole area, the whole polder area, will be inundated twice a day during high tide. The reason why they did this depoldering was also because they want to make more nature. And it's also to compensate for the nature of some buildings in the slough area near Vlissingen. And for our Belgian friends, it also helps to lower the water level crest in the city of Antwerp at high tide or storm tide with between 10 and 15 centimeters. So you see there's quite a huge change of the area. That's what you see over there. That's the old levee. The new levee was built, the new Hedwige levee, because that was built, they could depolder the whole area. And on 1, 2, and 3, you see the location where the 3 creeks are being dug. So the main focus of the Polder2C, or this, I repeat, protection against and adaptation to the consequence of climate change in coastal regions, and that used for the Hedwige-Prosperpolder to turn 6 square kilometers into tidal nature area. And what for us, the red line on the picture is 3 kilometers of levee, which we use for testing. And we call it kind of playground for hydraulic engineers. We didn't do this alone. I think it's very important to mention that there was a kind of nice partner consortium consisting of the Ministry of Infrastructure and Water Management, Rijkswaterstaat in the Netherlands, the TU Delft, the Province of Zeeland, University of Applied Sciences or HZ in Zeeland, and the Ministry of Defense, the Army Corps of Engineers or the GENIE, and of course the STOWA. Our Belgian partners included the Ministry of Public Works. There were 2 departments partner in our project. One is Flanders Hydraulics, and the other was the Flemish Waterway. And also the KU Leuven, which was one of the leaders of Work Package 3. We have 2 English partners, the Environment Agency and Southwest Water. And now you're asking, why is the drinking water company partner in the flood defense? Because in England, a drinking water company is responsible to keep its assets flood prone. And we have 3 French partners, CERMA, ESL Engineer, and University of Lille, and they were the magicians with data. We also had a lot of hands full of observers. We had about 8, 9 observers from the Netherlands, which both universities and water boards. In Belgium, they have also, it was more academic. I think the Belgian partners, there were a lot of universities, but also the INBO, this the environmental research group in Belgium, and also the dienst noodplanning van de gouverneur van de provincie Antwerp. That's this kind of emergency response group. In the UK, the partners were more or less associated with the Environment Agency. So there were also H.O. Wallingford, Syria, which is a partner also for the International Levy Handbook, University of Sheffield. And France, we have a lot of partners, both from, I think, derived from CERMA or ESL, and they're more, let's say, like local stakeholders, most of them, let's say. Not only ICOL, the International Commission of Large Dams, was more or less on a more national, international level. So it's very interesting. You see the mixture of partners and observers, and formerly observers are also called partners observers. What was the Polder2C project looking at? The focusing of project is flood defenses, destructive full-scale test, continuous overflow test, wave overtopping test, wave impact test, and levee breach bureau. I think what the experience with the TU Delft did was flashing people from a levee we could call, let's say, a wave impact for human people. We also have emergency response. One of the big achievements, I think, was our inspection app, App2C. Emergency measures, placement and testing, mostly in combination with flood defense destructive test and damage repair and breach closure. So I think there was a quite of interesting combination between flood defenses and emergency response, where indeed emergency response was the countermeasure of some flood defense damage tests we did. And we spent a lot of energy on the knowledge infrastructure, where it was educating the next generation, sharing knowledge, toolboxes, data wizards, student involvement. Good to mention, I think, would be here the levy challenges and the summer or winter schools we did as a project. Now, how does that look like when you do continuous overflow experiments? We did scenarios with varying grass heights, anomalies. Maybe by chance we found out that animal burrows, vegetation, cliffs are really important destructive elements on a levee, and they cause much more damage than we had thought on forehand, let's say. And we did after especially with the damage through anomalies, we did a lot of emergency repair measures. Now, what do you think about repair measures? Is that we did continuous overflow experiments on coconut turf, T-vector, a kind of astroturf, and EPDM. That's what people use on their roofs to keep their house from leaking. Now you see that there are all different combinations, all different technical requirements, but somehow the coconut, although it was maybe the most light one, was really an interesting discovery in our project. Here you see a sheet where we explain something about the wave overtopping experiments. We did a reference test. So just with just a normal grass cover, we tried to do a scenario where we did wave overtopping on a tree. We did a scenario with an obstacle, brick wall on a levee, animal burrows and the mitigation measures, and the lime-treated clay. And there was artificially reinforced clay with lime. I think the most interesting things was that the animal burrows, and especially the mitigation measures for it, were much more destructive than we have ever thought. The picture on the right-hand side shows that there was a kind of hydraulic shortcut between, let's say, the water over the grass cover and through the hole into the sand core, and that you see a kind of local micro-instability, which caused a huge hole in the levee, where whole chunks of clay combined with good grass cover were so spoiled, flushed away through the waves. So that was really quite an interesting but also concerning element of our experiments. We tried to do some tidal marsh on breeze grow. We did some experiments with tidal marsh and without tidal marsh, although we had planned to do it on the levee in the Hedwige, and the first experiments were already there, but the definite experiments were done at the TU Delft, the flood-proof Holland site, due to some logistical reasons, and also because of some permits that we were not allowed to do it over there. But I think Mario van den Berg is doing it in his NWO research, PhD research, and in a few years' time you will get a kind of very interesting results of the tidal marsh. But I'm not allowed to spoil already the results of those experiments, but I found them very interesting. And the nice thing is we did some wave impact, that is with another machine that is really giving the wave impact energy, putting on a local thing. The Agricultural University of Wageningen did some experiment with turf debris. And I think the wave impact is that huge that if the combination between the grass cover and the underground of it is not good, then you got quite fast some big damages. So now one of the specialties of our research, although not on forehand we thought that it would be that important, at the end you see that animal burrow detection and mitigation measures are really taking hold on. We did some non-destructive detection techniques. Probably we'll see in another vlog, you will see Vana Tsimopoulou telling you much more about this. So I'm not going to spoil it here, but we did some non-destructive tests and we did some destructive tests with grouting and excavating, and especially for the image for the people, how huge those holes under the ground are. The grouting and the excavating of the grouting was really an eye-opener. And the other thing what I found out is that smoke test is very easy to give people some visualization of how the holes are connected on a levee. And the nice see in the picture, the diagram on the right-hand top corner is that you see the difference between a mole system and a mouse systems. Moles are much more linear and mouse are much more scattered all over a levee. And in the presentation of Vana, she will explain what the reason is behind it. One of the nice also thing is that we try to professionalize emergency response and also do different phases with also professional levee managers and also with more volunteers. And we use the inspection tool App2C, where we not only which is working on an XIZ coordinate, and then where you with a photo of the location where the damage is, but also with a kind of scroll down menu, you can quite easily fill in, and then you get a kind of standardization of the emergency response locations and what measures can be done through the dashboard. It's quite a next step in emergency response, I would say. And at the end of my presentation, you see how the area changed from an levee agriculture thing to an area nature area without levees, and where you see a lot of much more influence of the tide, and the complete look and feeling from the area is changed. So this is now a nature-prone area. Thank you very much for your attention. And if you have you want some more information, just go to www.Polder2C's.eu, where you can find all the results of the experiments, all our reports, all vlogs, all our videos, all kind of background information, and also some contact details if you want to have more research questions to the researchers themselves. Thank you very much for your attention, and I really do hope you liked our experiments of Polder2C. Thank you very much.